Hey, I'm running late tonight. Look at that. That's awful. That's awful. I was just sitting here too. I was I was uh I was reading this article that I saw earlier today, and I didn't pay any attention to it. Um and maybe what I can do is, well, let me pop open the chat. Nanu. Hope all is well with you, OMC Triple X. What I'm going to do is I'm going to pop out that chat because I think maybe let's just look at this article to begin with. You've stumbled onto, by the way, a live stream called Astronomy Daily Live, and you can call me Cosmic. We're all cosmic, but I'll distinguish myself tonight at least. Um, and this is a daily live stream where a group of friends comes together and talks about astronomy for an hour, maybe a little over an hour, something like that. I want to respect your time, and I could go on uh, all the time. So, but that may not be extremely entertaining. So you just get little daily bites. Yeah. So hope everybody's doing okay. This show is for everyone. So whether you're new to astronomy or you're an amateur or maybe an advanced amateur or a pro, you are welcome here. And yeah, let's have a conversation. I can leave that up to you. Um, so, we can do a Q&A, talk about telescopes or equipment, cameras. Um, we can talk about research and what astronomers do. We can talk about collecting scientific data and reducing it and extracting information out of it by making various kinds of measurements. Um, we can talk about astro-art. There's a connection between art and science that um, is just beginning to, I think, sort of become realized by a large enough population that it really, the old STEM isn't STEM anymore. It's STEAM. It's STEAM. It's STEAM, and the A stands for art. So I think that's uh, a much better way because all those uh, disciplines are uh, sort of one and the same. Yeah. So yeah, I'm an advocate for STEAM, definitely not STEM. Okay, OMC Triple X has thrown out a question, but I wanted to show you this article first. So let me pull it up here first. Uh-oh, I've got a kitty on the lap. All right, what I'm going to try to do. Okay, I'm going to uh, share my screen. Share the screen. Share the screen. Go to infinity. Boom. I'm going to hide that. I'm going to go over here. And we're going to go here. And then I've got the article up on my Linux machine, but I think I can probably do pretty well. Phys.org news 2018 hyphen 02. Oh, let's just do this. Let's just do news. Betcha it's near the top. Huh? Okay, maybe I just have to go to phys.org. I'll figure this out. There it goes. New Horizons captures record-breaking images in the Kuiper Belt. So it says NASA's New Horizons spacecraft recently turns its telescopic camera towards a field of stars, snapped an image, and made history. So it's all this is they were taking a calibration image and captured the image of a Kuiper Belt object, and it's just the furthest from Earth that such an object has ever been photographed. So it's a different angle, it's a different perspective. So yeah, kind of neat, interesting. False color images. KBO 2012 HE85 is, for now, one of the furthest from Earth ever captured by a spacecraft. At the time, it was among the closest observations yet made of the mysterious distant objects known as KBOs. Yeah, so pretty cool. Pretty cool. New Horizons is definitely doing some pretty interesting things out there. Hope it lasts for a while. That's uncharted territory out there. Really don't have any understanding or even comprehension of what's going on in that area of yeah, it's still part of the solar system. It's just way out there. All right, I've also got a Discord channel that you can get onto. I'm going to stop sharing, and I'm going to go back to that. Cool. All right. I've got a Discord channel that I will share in the YouTube chat. Let's see if I can do this. Left-handed. I know I can. I know I can. Just have to hit the enter key. Yay. Okay, OMC Triple X had a question. So here we go. I'm reading it for the first time. How fast do radio transmissions move through space? Should I read them all? Yeah. Well, okay. How fast do radio transmissions move through space? Radio is light. So radio transmissions travel at the speed of light. Question 1B. If you are on a ship going to the next planet at slightly faster than the speed of those transmissions, when you got to the 1970s transmissions. Oh, okay, yeah. Hypothetically, yes. Hypothetically, yes. But as far as we know, can't go even nothing except light itself travels at that speed. Everything else travels slower than that. So supposedly, at least, and yeah, pretty good evidence, I guess, to say that there is a speed limit, and you cannot go slightly faster than that. So yeah, you'll never catch up to 1970s TV and be able to watch it. But if you could, then absolutely, sure, you'd see that. The signal would be very, very, very weak, right? Because it dissipates at an inverse square. So as it moves out, the signal strength decreases to the square of that. So it gets pretty weak pretty fast. square term is pretty strong. And there's Uncle Bill. Hey, nice to have you here again. Gathering of the circle of friends talking astronomy. Um, don't really have anything in particular in mind tonight. I was talking about astro-art a little bit and how, you know, science and technology and engineering and art and mathematics, you know, they're strongly connected. So I'm a big advocate of STEAM. So plus you know, STEAM is composed of the most amazing molecule in the universe. So uh, I like STEAM. I like STEAM a lot more than STEM. So this is dihydrogen oxide tonight, going a little strong. You know, it's Friday, isn't it? Yeah, I think it's Friday. So yeah, you know, go for it. You know, little high potency uh, dihydrogen oxide. So cheers. All right. Well, what else is going on? I was looking through the Twittersphere uh, here right before the show. That's how I got diverted and was running a little bit late. Just sort of looking through the Twittersphere, searching for the word astronomy, because sometimes you get some interesting news tidbits. Everybody's still pretty excited about the car up there with the Starman. I've seen a few uh, images now, and I think that um, I think that David Sims got the calculation right, and I think all of those things that are being seen are not the Starman, are not the car at all, but are the third stage. So that's just you know, based on the numbers that David Sims worked out for us last night. Uh, yeah, that little car is just too small and therefore too faint to see. Um, so yeah, they're seeing a rocket body for sure. You know, 15th magnitude. That's easy. It's super easy. So yeah, very cool though. And yeah, I figured others would consider doing that kind of thing. So you know, if nothing else, if I you know, injected that kind of thought into the universe to inspire others, you know, to go for it, then mission accomplished as far as I'm concerned. So yeah, some good pictures too. Good stuff. Yeah, yeah, real pros for sure. Yeah, that's exactly right. Yeah, copyright, copyright. Yeah, I've well, fairly recently, probably within the past 5, 6, 7 years or so, I've realized uh, how creative science is, and because it is creative, I found that I can sort of use that same, you know, sort of that same vibe to do artwork as well, and it feels very much the same. Um, Probably at least some of that I guess would have to do with the fact that I'm I'm still programming to create the art. So instead of writing code to reduce some data or do some kind of scientific thing, I'm writing code to draw for me because I can't draw for shit. So I mean, no way. And kind of stuff that is pretty complicated. So it's nice. It's nice just to be able to tell a machine to draw it for me, and that works out really well because uh, uh, the, the little bit of control freak in me, uh, you know, really appreciates having that amount of control, like total control. so so it's cool. It's cool. I wonder, did I don't know if yeah, I think I've shown some of my artwork on this channel. I can do that again just for a little bit, if that's all right. It's on a thumb drive. Let me go grab that. It's right up here, there, right up there. Okay, so let me go get it. Now I'll plug it in, and I will share my screen again. I like sharing the screen because then you don't have to look at this. You can go to infinity and then go from there. Open files, view files. It's under art. We can just go through these again. I'll just click through them. So these are low resolution images, very low resolution. But I put little Dao De Ching quotes in there just to spice it up a little bit, make things interesting. This is all the same data, just sort of different, obviously different colors and sort of different configurations. But this data is all the orbital motions of the four Galilean moons of Jupiter. So it's a little bit hard to see in this one. I'll point it out. You can start seeing it here. So here's the orbit of Europa. Here's the orbit of Ganymede, and here's the orbit of Callisto. You can sort of make out the orbit of Io in there. Oh, let me go back. So here's the orbit of Io, this blue one. And then you can sort of make out the orbit of Europa. And then there's Ganymede. That's the third one out. And then here's the fourth one out. So that's the first one that I ever made. And again, that's very low resolution. This is the one that won the honorable mention at that art show that I went to a week or so ago. So that's not. I think the color on this screen is a little wonky. I think. Let me. I'm gonna try to pull it up here on my smartphone. I think the color is not exactly what I'm seeing on my laptop screen because the outer thing should be pretty yellow, and it doesn't look yellow on my screen. But I'm gonna look at the live stream here and and find out. Dun, 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 dun. Oh, that looks better. Yeah, yeah. Okay. So on the live stream, it's got some much better color to it. So good, 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 good. I'm glad you're seeing that as it should be, and not as it is on my screen. So here's these things are called, well, I call them snowflakes, orbital snowflakes. So again, you can see, you zoom in on this. This one isn't the best one to see that effect. Well, let me go back to, let me go back to that one. We can see it here if we really look. So you can see that there's this inner circle, that's Io, and then the next one is Europa, and then the next one out is Ganymede, and the next one out is Callisto. And again, this is using all the same data, exactly the same data, just using some artistic license. So this one's called Magnetic Labyrinth, and this uses data from the Juno spacecraft as it moves through the environment of Jupiter in its 53-day orbit. So what this is, this data is taken from an instrument called a flux gate magnetometer. So it measures the magnetic field strength, the local magnetic field strength in an XYZ coordinate system. And then the position of the Juno spacecraft uh, is on a coordinate system called planetocentric, which is a designated single point on the planet. And so from that point of view on the planet, as Jupiter rotates, Juno appears to rotate in the sky. I hope that makes sense. So these rings that you're seeing is that motion. So it's as if you were standing at a point on the planet Jupiter, and we're always looking at Juno over the course of almost one orbit. You see, I stopped it. I think this is the beginning. I think this is the beginning, and this is the end. It's almost one complete rotation of Jupiter. Um, and you can see just slightly, if you really, really look at this hard, this side is a little further out than this side. So Juno's getting closer to Jupiter. Uh, this is over the course of, as I said, almost one planet rotation. So that's about 11 hours or so. I think I did like 33,000 seconds. So however long that is. So all I have to do is reach out for my handy dandy calculator, and 33,000 seconds is 9 hours and 10 minutes. So 9 hours and 10 minutes worth of data. So this inner ring is the magnetic field strength in the x direction. The next ring out is the magnetic field strength in the y direction. And the third one out is the magnetic field strength in the z direction. And the brighter it is, the stronger the magnetic field. So low magnetic field strength here, very high here, low again, kind of gradually goes up to high, then drops down and goes all over the place. So then what I have here is I have 3 grayscale rings that I can designate as, let's call this one red, this one green, and this one blue. And then I combine that to make this outer ring. So these 3 rings are combined, red, green, and blue, to make this. And then I also, rotated the rings around a little bit so it looks like a maze or a labyrinth. that kind of thing. So just a lot of artistic license. And I sold 2 of these at the art show. People really like this. A tree ring scientist uh, bought one of these. So I thought that was just awesome. Isn't that cool? So this again is the same Jupiter data, just I've added sort of a temporal dimension to it. So they begin to look 3D and sort of odd shaped. Um, I sort of these to me look like sea creatures, but people see all kinds of things in these, and that's part of the thing with art is that you can put your own interpretation on things. This is using the same Jupiter data as as those other ones, just a different perspective. There's just a darker version, enlarged a little bit, different ones. So this again is the same um, Jupiter moon data, just presented in a different way, and a pre-selected color palette. That's kind of the neat thing about um, digital art, is that I can pre-select the the colors that are going to be used. So if somebody likes this pattern but doesn't like the color, well, I can just change some variables in the code, and it'll make exactly the same pattern, but with colors that you might want. So that's again the same Jupiter data as before. More Jupiter data. I think that's it. And then now this I know doesn't show up very well, but let's play it anyway. What the heck? So I can make video, and this is not going to show up very well on the live stream. It's going to be really, really jerky, but I'll do it anyway, just so you can get an idea of what's going on. It's trying to load. It's trying. There it goes. There it goes. There it goes. So you'll definitely not see it quite like this. But I'm gonna watch the live stream here too and just see how it looks. Yeah, that's not too bad. You get an idea. Pretty jerky. Pretty jerky. I've got this longer one too. I'm not going to play this longer one all the way through, but we can certainly take a look at it here just for a second. Pretty much the same thing as you saw before with the blue one. Different different resolution, I guess you can say. And I can get into these other things like that. I'll skip ahead and we can go to that. I just have a selection of these. Kind of interesting, I guess, huh? they're definitely fun to make and definitely interesting to watch. You see all kinds of interesting things in here. It's neat when you consider the fact that this is using, you know, like real astronomical data. It's not just, you know, sort of random or mathematical functions or anything. This is the real deal. And again, this is the same Jupiter data. All of this is. Gets pretty exciting. All right. Well, enough of that. Enough of that. Let's uh, let's get back over to this. Stop sharing. Go back over to this. Ta-da! Where is it? There it is. Well, cool. I'm going to go to my list. Hope everybody got a chance to listen to the Hearts of Space this past weekend. It was a guitar uh, focus, and yeah, it was okay. I can't say that uh, mm, it was a pretty average one. So sometimes they have some real gems. Sometimes they have some real bomb. Most of the time, you know, they're right in the middle there, and really nice, you know, to listen to. Listen to program number 1168 yesterday. I had to do some driving, so just put the headphones in and listen to 1168. And 1168 is pretty good. I want to listen to that with some real headphones on and be able to sit back and relax and really listen to that because which is you lose a lot. Cheers. So yeah, you know, I try to mention this as much as I possibly can. You know, if you're interested in getting getting um, getting into astronomy, especially you know if you're interested in any kind of research or anything, there's more and more data sets that are coming online all the time, and there is there's so much um, data available that if you have some kind of interest um, at all, uh, there's probably already you know some good data for it. So you know you don't have to have a scope, you don't have to have anything anymore. You just have to have you know the I guess the resources you know to do the kind of work that needs to be done to either make the measurement that you want or do whatever. And shown you Iris, which is the solar telescope. It's also an 8-inch, just that size. Uh, that's continuously looking at the sun, and they're looking at it in the ultraviolet, and they're taking images, and they're also taking spectra. So they're looking at certain um, wavelength regions because there are interesting spectral features there that can tell them a lot about you know what is going on at a particular location on the sun. So you know what material is there, how it's moving, you know the strength of magnetic fields, lots and lots of stuff you can extract from spectra. You you can get a sense of how much stuff there is. You can get a pretty good sense of how hot or cold it is. Most of the things on the sun are pretty hot, relatively speaking. So, but there are, relatively speaking, some colder regions on the sun and some hotter regions on the sun. So that's a really, really great resource, and their data is available. They're calibrated data. Okay, you don't even have to take calibrations. Okay, is this awesome or what? Okay, because as I've described at least a few times now, taking calibrations through through any kind of instrumentation at all is tedious, time consuming, and when it comes to actually processing it and then using it to process your data, it's a royal pain. It's a royal pain. So all of this data, okay, you can get um, you can get raw, you can get all the calibration stuff and do it yourself if you want. But you can also, you know, read the papers on describing what the processing is and how they come to their processed calibrated data. And if it looks okay, which at least in my opinion, the iris stuff does, then it's calibrated. It's done. So you just have to sort of take it and do what you can with it. And the only thing that you have to do, and rightly so, is that you have to credit Iris for all of the data. But hey, if you're doing some cool stuff, that is really really interesting, um, that's easy. That's easy. Don't leave that part out. That's the best part. So yeah. So Iris is a great resource. There's Gaia now. That's a star catalog. I don't. I have to look a little bit more into Gaia to be able to describe everything that it contains. I definitely know that it uh, is a database of star positions, so it definitely does all the astrometric stuff. But I think it also does other things too. I think it also, uh, might do non-stellar objects like the galaxies, um, some clusters, nebulae, that kind of stuff, right? Um, got a kid. I've got a kitty climbing the wall. So yeah, some pretty good stuff there. It's just a searchable database. You can download in various formats, including CSV, a couple of different formats. You just do a search. There's different kinds of searches as well. I haven't looked at Gaia in in a little while at least. So there's also, the Sloan Digital Sky Survey, which is also more or less just an astrometric catalog, just positions of stars. But no, the SDSS gets into other things too. Yeah, a lot of them do. A lot of them do for sure. Anything going on in the chat? What is the CD collection hanging behind me? That is just a random selection of CDs. Instead of, you know, uh, if what I just don't like these, like in a book or something that I have to page through and page through. So I've got these organized by artist, and if I want it, I don't have to do anything, right? I just have to reach out and grab it. So I've actually got these along most of my walls in here, and they go up. I don't know. It's probably it's not. It doesn't go up the entire wall. It's probably it starts about 2 feet off the ground and probably goes maybe 6 or 7 feet up or so, and it's almost all the way around the entire room, just full of CDs. Some of them are double stacked and triple stacked. so it's almost as bad as having a book then, because I can't see everything. See, I want to be able to see everything. So that's it, and it's just a random, collection of CDs that I either used to like to listen to or still do. So yeah, but yeah, I figured that was a pretty interesting way to both decorate a room and have access uh, to some music that I like. Easy access. The, one of my favorite words in the whole world is easy. Easy. I definitely want to do things easy. It's fun and challenging to do hard stuff, but given the choice, I'll do easy stuff. I like doing hard things, but I prefer easy things. So yeah, having easy access to a CD, know where it is. So yeah, I actually have I've ripped most of these to MP3 as well. So these actually don't get played very much anymore. They are they are much more of a decoration now than anything else. So yeah, and I think I've pointed this thing out before. Right, this is the first 8.4 meter mirror ever made, and put that up a little bit. And you can't see me, but I'm back behind here somewhere, something like that. But that's when it just had come out of the oven. This bottom part is sort of the bottom layer of an oven. There were walls here, right? Walls here, and then a cover on top like that. And then this is actually on like a second floor. So you can sort of see a little gap in the floor right there. So underneath this is is all the electronics and all the high amp things and all that. So this is what's called a spinning oven. So they this this mirror is mostly hollow inside. It's got a honeycomb inside, and so they carve out these shapes. These hexagonal shapes. Hexagons? Are they hexagons? I think they're hexagons. And they lay all those out, and then they put this glass on top of these forms. Enough glass such that when the glass melts, it oozes in between the gaps in the forms and oozes onto the bottom. So you have a bottom plate of solid glass, and then all right, hold on a sec. I have to save a kitty. Hold on. These kitties have such big problems, major problems. They're just very, very serious. So it's enough glass to make a pretty thick bottom plate, and then this is a couple of feet thick, but it's mostly hollow. And then there's a plate on top. So you got to put enough glass in there so when it melts, it fills in all the gaps, makes the bottom plate, um, make, makes the top plate. And once this glass is a liquid, and it's as liquidy as water when it's at temperature. I don't remember what the temperature is. Uh, yeah, Uncle Bill, I'm absolutely sure that it's hex. Yeah, for sure. Uh, so once this all melts, they start to spin the oven, right? They spin it. And I think it's something like the highest rate, if I remember right, is something like 4.5 RPM, something like that. So you've got this this top thing is about 10 meters across, right? 10 meters across. So you got this thing that's 10 meters across, maybe 6 feet high, because it's got walls and then a cover on top, maybe 5 feet high or so. This whole thing is rotating at four rotations a minute. So it creates a wind, right? It creates a wind, and what that spinning does is it you know you've probably done this. Take a bowl, fill it with a liquid, and spin it. Edges go up, and the center drops, and it turns into a sphere, into a spherical surface. So instead of having to, start with a piece of solid glass and grind all that stuff out, basically carve it out, um, they just spin it into a spherical surface, which is much closer to a parabola than a plane. So after it's spun like this, they have to they have to do a lot of work to turn that into a parabola, but it's a lot less work than having to start from the beginning. And uh, doing a mirror like this solid isn't going to happen. It can't support its own weight. See, this is a very, very lightweight mirror because it's mostly empty. So yeah, that was really, really fun. I got to I had a hand in the uh, in the polishing of this mirror. In that I was operating a camera at the time that was uh, well, I guess a combination of the one on hand and sort of the best thing to use. So what I had to do is I had to situate myself at the center of curvature, which is at twice the focal length. So I think this is like I want to say like an f 1.5, 1.3, something like that. So the focal point, let's just say it's an f1, is 8.4 meters above the surface of the mirror. Well, is about uh, 16.8 meters in the air. Uh, so I hovered above this mirror, um, pretty high up, and took a bunch of data, a bunch of interferometric data to measure the surface, to see how smooth it was at that point. So that was kind of interesting. But yeah, I think I cut out there for a couple of minutes, but I'm back. Um, anyway, so yeah, that was fun. It was really, really exciting to be there when this mirror was made, because it's the first of its kind. And this mirror, along with its twin mirror, they made another one, a second one. Uh, this mirror and the other one are now the two mirrors in the Large Binocular Telescope, which is the largest optical telescope in the world. And I live right next to it. I see it. I see it every day. It's a big white eyesore up in the mountains, and I love it. And in fact, oh, okay, I'll do a little bit more show and tell. So speaking of the glass that they use, this is a sample. You can sort of see how big it is. This is a rejected piece. It had and I've I've dropped this a few times, so it's actually more damaged than what it was when I originally got it. But if there are any kind of flaws, I think any kind of like air bubbles, anything like this. But this stuff is called zero doer. Zero doer. It's borosilicate um, doesn't doesn't change shape with temperature. So it's uh, most glass expand, and most things expand and contract when they get hot and cold and hot and cold and hot and cold. This stuff is very, very stable. So you can sort of see what that looks like. They had boxes and boxes and boxes of this stuff, um, rejects. So they were pretty much handing these things out like candy. And so I did exactly the same. I would grab several at a time and I'd give them away to friends. And this is the last one I have left, and it's the one I'm keeping. So yeah, it's not going to go anywhere at all. But it's really it's a strange feeling glass. It almost feels like really 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 hard plastic, and it's got a you can't really tell. Maybe you can. Can you see any of that blue in there? It's got a really strange blue tinge to it. A really strange. I'm looking on the live stream to see if the color's coming through. Yeah, there's a little bit of color there. Yeah, well, I'm glad you can see that. Yeah, because that's kind of interesting, I think. Anyway, so this is the glass that made or was put into that mirror, and the mirror lab, continues to make mirrors today. So very very cool. Yeah, that was a fun thing to be sort of involved in. Not really in any direct way, but it was fun to help out a little bit and definitely be a part of that photograph. That was cool. That was very cool. Yeah, definitely a highlight. Yeah, yeah. You would uh, you'd see that the whole thing, just looking at it, has sort of this strange frosty blue tinge to it, and I don't really know what's going on there. I can't really account for it. If it, I don't think it's any kind of coloration in the glass itself. I think it's something optical. I think, but yeah, the refractive index. I don't know. I don't know, but it's pretty cool, pretty fun. So big shout out to Weekly Space Hangout. They're completely awesome. Really, really good show this past week. So check that out for sure. Um, Dennis Hands is still doing his thing on Mondays and Wednesdays. It's Monday at 8 a.m. Eastern Time and Wednesdays at 8 p.m. Eastern Time. He's on the East Coast of the United States. And he's on Snapchat. He does a Snapchat, an hour long, and I think he calls it "Let's Talk Astronomy." And he's an educator. He's a teacher. Cheers. And he's got a great live show. Um, uh, he is a teacher, so that that's sort of his means of delivery, and I like him a lot. And he knows his stuff, and I really really like his show, and I encourage you to check him out. Um, he's on. I think the recordings for Periscope stay up for a few days at least. So um, you don't have to necessarily check him out live. I rarely do. I check him out, the day after or a couple days after, and yeah, thoroughly enjoy him. He's got great sense of humor. Uh, so yeah, very very awesome. Um, uh, Big shout out to Deep Astronomy. Tony is rocking it over there. Uh, Actually has had some pretty good guests past couple of weeks or so, and he gets too frustrated with the technology, and yeah, but I think that's his personality, and so I appreciate that, and you know he's he's going after really high quality production, and that is definitely something that I'm aiming for also. But I'm guess I'm pretty laid back in that I'm not really gonna sweat it all that much because I think the content um, is more what you're after than any kind of you know uh, high quality production. If that happens, if they have the opportunity, to make improvements, I definitely will. So yeah, it's not as if things are going to be like this. I mean, look, this literally this is a $5 uh, um, webcam. I didn't even know they could make them for that little, right? Much less sell them for that little. So yeah, this is, as I said right at the beginning, you know, this is the lowest it gets, and it can only possibly get better. I mean, I guess it could get worse if the camera breaks, but that'll probably be the last thing to break. So yeah, uh, but anyway, um, check him out. He's on several times a week. I know he's on Thursdays at 3 p.m. Eastern time. He's also on the East Coast. I think he's in Florida. Yeah. Um, so definitely check him out. There's a lot of room for all of us. We're talking about the cosmos here. We're talking about the universe. There's a lot of room in the universe, and so there's room for all of us here. I don't I don't feel any any sense of competition at all. Um, in fact, I'm starting to feel a little bit of a camaraderie. Um, I'm way behind, way behind, and I have much to do. But yeah, it's feeling nice, and I think I'm filling a niche. Definitely want to get more viewership. So yeah, if you haven't already, and you're watching this in the future or watching it live, uh, make sure to hit the thumbs up, because I think that helps the YouTube algorithm make suggestions. And at least a lot of the things that a lot of the YouTube channels that I've found have come through, suggested ones, and so yeah, hit the thumbs up, and then definitely also share. Apparently that helps as well. So yeah, very cool. And definitely, if you're new to astronomy, the best advice that I can give um, is look for a local club or society, and there's usually at least one in every town, even smallish ones. Uh, Oftentimes have a pretty active group, because the small towns you're talking darker skies, and so there's more that can be done in a dark sky than in the middle of a city. So definitely, if you're new to astronomy, and um, you know, if nothing else, you know, find out things, get more questions answered. Go to a local astronomy club. Find out. They usually have like monthly meetings where they'll have you know one part sort of business and all that. They usually have a presentation of some sort, either from a member or from a guest, and it's fun to be a presenter at those kinds of things. I've yeah, I've done that a few times, and yeah, it's great fun. Questions are good. I think people learn a lot, and you know, uh, you go to a presentation, to learn things, and you can ask as many questions as you want, and then hook up with some people afterwards, um, and see what kind of equipment they have and what they're doing. Um, Most of the time, clubs will have at least a monthly star party where a lot of the members will go out under a um, they'll go out under a dark sky with a bunch of telescopes, and you'll be looking at different things. If you're in the market for a telescope, the best place to go is to a star party where you can look at a bunch of different kind of scopes, looking at different kinds of objects. You can ask, um, you know, the person running the scope uh, if they could point it at a planet or if they could point it at a galaxy. Um, they usually no hesitation about that. I mean, there wouldn't be for me, and I've attended thousands of star parties. At least it feels that way. So yeah, um, anything that anybody wants to see, I'm going to show them for sure because it's awesome. It's awesome, especially the first time. It's I've been lucky enough to be able to show people for the first time lots and lots of things, and it's it's awesome. It's absolutely awesome. You know, People are most impressed by like Saturn, right? When they first see Saturn, it's people cry, and I'm right there with them every single time. I've 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 looked at Saturn. I mean, I've got an image of Saturn in my head because I've um, looked at it so many times. But every time I say it, it's like that is very cool. That is very very cool. So all right, look, I am worn out again. I'm worn out. This dihydrogen oxide is not doing it for me tonight. It's just not. So I think it's been a good hour. Newbie tip: research little known small observatories in your area that might be hosting star parties. Yeah, yeah, there are um, past past 20 years, I would say, the number of sort of personal observatories I think has popped up. Um, just a personal observation, I guess. I don't know. I just don't remember those kinds of things when I was a kid. Nobody had an observatory. A lot of people that I knew, had telescopes, but nobody had observatories. So that's sort of a newish thing, 20-year-old type of thing. But cool, yeah. Hale-Bopp was one of the good ones for sure. I think for me, Hyakutake was the great comet, and I think I've told that story. So I'll hold off on that for a later time to relive that one. But I think Hyakutake was the one that really got me. So Hale-Bopp was brighter, but it was really small compared to Hyakutake. So but yeah, seeing any comet is pretty cool. I saw Comet Halley. mm, I saw Comet Halley every clear night from November 1985. No, sorry, August August 1985 through June of 86. Every clear night. And where I was, there weren't a lot of clear nights, but there were enough that the last time that I saw Comet Halley, I think it was probably 5 years, 5 or 6 years, uh, until I looked at another comet because I was just, I'm like, I'm not going to look at any more comets. I'm sick of comets, sick of them. But then, after after a few years, that anger goes away, and so yeah, I started appreciating the comets again for sure. So very cool. Okay, I'm gonna get out of here. Hard Labor Creek Observatory. What a name! What an amazing name. Yeah, yeah. Is it like a roll off roof or is it a dome? Because a lot of the roll off roof ones, yeah, they look like a shack or a barn or something. Funny delay. Uncle Bill, are you watching 40 channels tonight or 50? All right, well, cool. I'm going to get out of here, respecting your time. And this is the cool thing about a live daily show. Like there's no agenda. I don't feel as though I have to, you know, focus on a particular topic and get through it all and hurry and all of that. It's very casual, very, very casual, very, very fun. And just astronomy, just astronomy, throwing some science in there. Uh, yeah, cool stuff like that. Wow. Wow. Okay, so domes. Hardly know it's there, and they're domes. Pretty cool. Pretty cool. All right. Well, look, I'm gonna get out of here for today. Uh, in less than 23 hours, we're gonna be right back here in the circle of friends, talking astronomy for hours or so. Usually a little bit over that. Getting some good counts on my plays. So yeah, I think right now I have to just continue this. Don't get don't feel discouraged or impatient or anything. Things take time. Um, I'm definitely still trying to, you know, sort of get the groove going a little bit. I think I'm doing all right. Um, yeah, I'm not going to sweat this too much because this is just fun talking about astronomy for an hour or so. So I'm not gonna worry too much about how it all flows and everything else. I think it flows pretty well, pretty well. And as long as I'm trying to always get a little bit better, um, I think I'll do just fine. Just got to stay consistent, got to be patient, and yeah, I think this will work out. It's definitely filling a gap in the current uh, astronomy live stream podcast space. So yeah, yeah, I think this will help. This will help the entire sort of community. So yeah, yeah. All right, I'm gonna get out of here for now. Yep, 20, 22 hours and 50 minutes, and we'll be back. All right, take care. Peace out.